Let me welcome you to the first lecture of surface mining technology. In this lecture, our lecture title is rocks, minerals and ore, which is basically a part of the introduction to surface mining. In our first week, we will cover the introduction to surface mining part. In this, the first lecture is related to rocks, minerals and ore, and this is basically related to the background. We have already introduced you to the subject. So, let us directly go to the objective of this lecture. This learning background for the course, learning objective of the course, learning outcomes of the course, these are already discussed. The textbooks and reference books are also discussed, and the objective of learning objective of this lecture is to understand the rock and rock mass and to understand the rock and rock mass discontinuity. In this case, let me give you the idea. For a mining engineer, our rock and rock mass is basically the medium. So, the medium which we are trying to excavate is basically the rock and rock mass. So, our perception related to rock and rock mass is different from the geologist. Geology people are interested to know the rock and rock mass for its other uses, but for the mining engineer, rock and rock mass is nothing but the medium, and we are interested for the different properties of medium, and based on that we will decide how to excavate that one and what is its economical benefit. So, first is that mining is defined as the process of obtaining or excavating minerals or rocks or other valuable materials, either solid or in liquid form. So far we are not discussed about the gaseous form of mining, but it may be in future that may come. So, petroleum excavation also you can term as oil mining, and in some cases also water mining is also possible. In fact, there are few instances where water is a very considered as a very precious and valuable material and is having significant economical value. But otherwise mining is mostly related to the solid excavation system, excavation of the solids, and obviously you remember that mining is carried out as a business purpose. So, we will carry out mining if it is profitable only. So, mining with a profit is a very important aspect. If profit is not there, mining should not be carried out. There are some cases where strategic mining is carried out, like say atomic minerals etc., which is required for other cases, but it does not have any commercial value. In those cases strategic mining is also carried out, but otherwise mining is carried out for having some profit. Some other cases excavation is carried out related to civil projects etc. The method of excavation remains same, or you can say similar with the mining system, but the purpose is different in those cases. In fact, we are having more than 4,000 naturally occurring minerals. These minerals are basically inorganic solids that have a characteristics, chemical compositions and specific crystal structures, and these minerals are found naturally in the earth crust. And you can define a rock is any naturally occurring solid mass or aggregate of mineral matters. So, basically earth is formed by the rock and rock is naturally occurred. It is a solid and a rock comprises a number of mineral matter. Characteristically, a rock comprises a number of minerals either in homogeneous or in the heterogeneous proportion. However, a rock is formed at once through the different geological activities. So, the rock is understood as occurrence of the rock occurred at once and different rocks may have different occurrence, or there may be simultaneous occurrence of the different rocks are also possible. Rocks are commonly having ingredients which are basically the mineral matters, and mineral matters are having their definite chemical compositions. Rock are usually grouped in three main group depending on its origin. One is igneous, another is metamorphic, and another is sedimentary. In our next slide, we will understand how this process are going on. So, first let us have the example of three types of these rocks. First one is the andesite, is an example of the igneous rock, and you understand that igneous rocks are basically the volcanic products. When the volcanic magma or lava is coming out and it is cooled down and formed a rock is called igneous rock, and this is happened on the extrusive condition where it is cooled in the open air, and if it is cooled in the open air it became fine grained, and this is the composition of this particular rock. In case of sedimentary rock, which is basically formed from the igneous or metamorphic rock, on their erosion and then the compaction under pressure is formed the sedimentary rock. So, this is the sandstone rock. This sandstone rock is a sedimentary rock and basically composed of the quartz grain, which is nothing but the silicon oxide. Okay. And marble is considered as the metamorphic rock. Metamorphic rocks are metamorphic rocks are basically the sedimentary or igneous rock further subjected to heat or pressure or maybe some magmatic contact, and by that pressure heat, because of these activities their chemical compositions are changed, often the crystal structures are changed, and in those cases it is called metamorphic rock. And marble is basically a metamorphosed sedimentary limestone which is metamorphosed to become the marble. So, composition of the limestone and marble is more or less same, but the crystal structure is different, and that is why marble is characterized as a different material. Now, let us have some idea about the rock mass. We have discussed already rock. The difference between rock and rock mass is that rock mass is considered when the rock is under in situ condition. So, suppose this is the earth surface and there is a rock layer here. So, if this rock layer is here and you have taken a cut piece, you have taken out this cut piece and you are now considering its properties, then it is called rock. But when that the rock is inside the earth, it is called rock mass. That means, when the material which is forming the earth crust is basically rock mass. I have mentioned the two letter here. Often rock mass is shown as the single letter and often a single word, and often it can be shown as the double word. So, the two common material forming the earth crust are rock and soil, and when the rock is inside the earth crust, it is called rock mass. Soil is basically formed by the disintegration of the rock by weathering activities of the nature. Thus, composition of the soil and rock are remain same, rock mass are in general same, but as soil is allowing the growth of the vegetations. So, most of the time soil is added with the different biomass or the organic matters, So, this is the characteristics of the soil. Otherwise, rock is situated in the earth crust as a rock mass, and when it is situated in the earth crust, it is associated with the different types of discontinuities. But before that, let us understand the general formation of the rock mass. Rock mass is basically coming out from the magma, or you can say cooling of the earth gradually allows the formation of the magma, and this magma is cooled and hardened and form the igneous rock. So, when the volcanic eruption occurs, whatever magma is deposited at this place, with the cooling of the same, it becomes a rock, and this rock is called igneous rock. But igneous rock is subjected to pressure, cementations, weathering, erosions. So, this rock with the air and water form the different grains, and in a valley these grains are basically deposited. Then these are subjected to pressure because of the burial of the same, and cementation occurs here, and by this it is gradually again become a rock, and that rock is called sedimentary rock. Now, this igneous and sedimentary rock, often they are subjected to high temperature and pressure and deform to metamorphic rocks, like see this is limestone. When it is comes under heavy pressure and the temperature changes, that is forming to the marble. Similarly, when already existing igneous rocks are available here, but again further volcanic eruptions occurs, then because of this heat pressure this may be changed, or this may be metamorphosed and become the metamorphic rock. And all these three rocks are subjected to weathering and erosion, and they form the soil. Then the vegetation growth occurs in this soil, and gradually that is added with the biomass. Now, when the rock, we have already discussed, when the rock is under the inside the in situ condition, inside the earth, that is having natural cracks, formation cracks, there are different discontinuities you can observe in the rock mass. So, we will discuss few of the discontinuities in this place. The first discontinuity which is observed in the rock mass is called fault. So, first discontinuity is the fault. So, geological faults are the planar rock surfaces along which one side has moved relatively to the other side. So, the faults are associated with the little bit movement of the rock positions, rock mass positions, and these are the different types of faults: normal fault, reverse fault, strike slip fault, diagonal fault or oblique fault. So, it is better that we look into the picture, and from that it is easy to understand. But here I would like to mention that you will find out in website there is a group, geological group. You will find out different geology related issues are being discussed there, and a good geological examples are also available in these groups. So, now let us see the fault. This is called normal fault, this is called reverse fault. That means, when the fault is creating an overhanging situation, that is called reverse fault. So, this is normal fault, this is reverse fault, this is strike slip fault, where the movement occurs along the strike direction, and when both the dip and strike both direction, when the movement occurs, then that is called oblique fault or diagonal fault. So, in this figure I am trying to show you that, say, this is the main, say you say it is a coal seam, say, or maybe a small material of some carbonaceous or maybe the shell, but this is the fault plane. You can see this is the fault plane. This fault plane is allowing the movement of this at this position. So, it is moved to this position. Similarly, this point is moved to this position, this point is moved to this position. So, this is called throw of the fault. You can see here, this is called throw of the fault. So, this position is basically shifted at this position. So, this is the horizontal throw and this is the vertical slip. Okay. So, this is the characteristics of the fault. Generally, a fault is defined with this angle and the throw. And what is happening because of the fault, you can see, if suppose consider it is a coal seam, if it is a coal seam, now the coal seam is shifted at this position. So, there is a shifting of the mineral origin source occurs, and that is why these features are very, very important and one must note about these features. The next discontinuity is fold. Folds are wavy form of rock mass and mostly observed in the sedimentary formations. Based on the appearances, there are different types of folds are observed. We need not to go into the details of this, but these are the list of these different types of folds, but we must look into the beautiful pictures of the folds. You can see this is the folds how it is moving in a wavy direction. This is a beautiful picture of Turkey. You can see how this complex fold is occurs in this place. This is the full picture, this is the enlarged picture of the above. So, this is beautiful fold you can see here. Bedding planes are defined as a plane of separation between the layers and stratification of the plane. Generally, it occurs like this. Suppose you consider the erosion occurs and the erosions are deposited as a layer here. Okay. So, this is the first depositions occurs. So, as it is transported by the water. So, it is deposited like here, say you can say as you see the deposition of sand in the river bed. Similarly, the next time again the further depositions occurs, that is again forming another layer here. So, when they are converted to a sedimentary rock with the cementation, pressure and cementations, then these layers, each layers are found prominent in the structures. So, these layers are formed and these are called the bedding planes. These are called bedding planes and mostly it is observed in the sedimentary deposits. So, you can see this is the one bed. This is another bed. So, these are considered as the bedding planes. So, these are considered as the bedding planes. Similarly, you can see this is the one bed this is another bed, this is another bed. So, these are the different beds which are formed because their origin time is different. There are different bedding planes may be in the other directions also. And the next one, which is very important discontinuity, is called a joint. Joint is a naturally occurred break or fracture, and it is continuously observed in the rock mass without any significant displacement. If a joint plane, prominent joint plane is found displaced, it can be termed as a fault or maybe the local fault, but if there is no displacement, similar continuation other joints are also available, then it is a called joint, or it is the main discontinuity plane in the rock mass. Joints are also like bedding plane, defined by its dip direction, strike direction and dipping angle. Joints are found in set, that means a family of parallel joints are observed. It may be in a number of joints may be observed in different places, in same places, and their spacings are more or less evenly distributed and they can be mapped accordingly. Joint, these fractures may be open, may be filled with other material or may not be filled, but a tight joint is also found where only cracking is found. Infilled by precipitated minerals are also called veins, where two joints are filled with some precipitated minerals, but these minerals are having some economic value, is called veins, and sometimes these are very important. And if it is filled by a solidified magma, then it is called dike. Now, in this picture, let us show you some joint. You can see these are the joints. Let us have another picture of this is also available in the next slide. Let us look into that. But before that, let us understand how to define a joint. A joint can be defined by the joint spacing. Joint can be defined whether the joint is filled or unfilled. Joint set is a family of joints more or less evenly distributed, and their mapping can be carried out. Their orientation, spacing and physical properties should be given, and this is already discussed. It is called vein and dike. A joint is described by the dip this is called dip angle or dip. The direction of the dip, if you are considering this is the, if you are considering in a plane, if it is north, south, east, west, then this direction is at which direction? If it is this direction, then this is called the direction of the dip. So, this direction means this angle of this with respect to north. This angle is called dip direction, and perpendicular to that, if this is the dip direction, then perpendicular to this is the strike direction. So, the perpendicular to this is, in this case it is the strike direction. So, this direction is called strike direction. So, a joint can be defined by the dip angle, dip direction and the strike direction. We will understand this in the next slide with a good picture. So, now you can understand the dip angle is alpha, strike direction is beta and joint spacing is S. Now, if you are considering this blue line, let me show the blue line. The spacing between the blue line is considered as the third set joint. This is third set joint. So, this is the spacing, S3 is the spacing for the third set joint. The this is the purple color is the second set joint and red color is the first set joint. So, for first set joint the dip angle is shown. So, dip angle which is shown here for the first set joint here. For this third set joint the dip angle is 90 degree, because this is perpendicularly cutting the rock mass. So, it is 90 degree. For second set joint, this is the dip angle, this purple color, this is the dip angle, this is for alpha 2, this is 90 degree, this is 90 degree alpha 3 and this is alpha 1 for first set joint. Similarly, you can see the S3 for the third set joint, this is S1 for the first set joint and this is S2 for the second set joint. And as this is the dip angle, obviously this is the strike direction. As this is the strike direction, direction of this one is expressed with the this is, if this is considered as the north, then angle between this is called the strike angle for the second one. For first one this will be the strike angle and for the third one obviously it is again, this is the strike angle is perpendicular to the, this is the strike angle. Okay. So, this is the way we can define, this is the way we can define the different joint sets, and a rock mass may have n number of joint sets. You can see in this case a same rock mass is having 3 set joints, one is of red color first set, purple color second set, blue color third set. So, similarly, you may have more number of joint sets also, whatever, if you are having another joint sets like this, that can be also possible. So, that will be the fourth set joint. So, like that way n number of joint sets are possible in a rock mass, there is no limitations of number of joint sets. So, this is another picture where you can understand this is which one is the strike angle, you can understand this is A is the strike angle. If this is the north, this is the strike direction, angle from that north is the strike angle. Then this is the dip angle is the B. If this is the horizontal expose of the dip, then the angle with that with the north is called dip angle. With the horizontal, the angle of dip is the dip angle and dip direction angle is from north, what is the dispersion of the horizontal component of the dip is, that angle is called dip direction angle. So, in this case you can see the spacing So, this is this picture we have seen earlier. So, in this picture you can see these are the joint sets and this is S 1, this is S 2. So, we are not discussing about S 2. So, if you are having joint sets like this is more or less regular, but it is not that always these are having same value of the spacing. So, you may have spacing like this. So, the average spacing you have to compute of the joint spacing, average joint spacing you have to compute taking the average of the different measured spacing. Similarly, you can carry it out for the other joint sets also. This is the second joint set. So, this is the way you can carry out and calculate the joint spacings. Often people are having some doubt related to the joint aperture. Joint aperture is basically the crack of the joint. So, these cracks may be tight, almost there is nothing, no difference between these, or sometimes it is filled or sometimes it is unfilled. So, this is called width of the joint or maybe the joint aperture. So, joint aperture and joint spacings are different. You can see in this picture, this is the joint aperture or joint width and that is filled with this material. You remember one thing, there is no relationship between this filling material and this rock material. These materials are different, this may be same also, this may be different also, their strength properties, their other things, whichever it is, they are having as per their independent criteria. So, it may be possible your rock is weak, but the filling material is more strong, or your rock may be strong, filling material may be weak. So, these are very important and these aspects must be considered while you are considering the joint. So, this is more or less about the rock and rock different discontinuities what we have discussed today. This is, I think, give you some brief understanding about the rock and rock mass properties. So, let us complete this class at this point. Thank you.